Is my screen still visible?
Yes, sir.
Yes, sir. Mm-hmm. Okay, so the k bar and omega bar is just a representation of k1 plus k2 by 2, omega 1 plus omega 2 by 2. Okay, so these are the some of the inferences that we make from this equation that we get. So the result is a fast oscillating wave that travels with a phase. We define two things. We define phase velocity and a group velocity. It might be difficult for you guys to grab it as of now, but then I will show a couple of videos. It's the same equation, but in terms of graphical representation and some sort of description as well. So that will give you a better understanding of this whole, why we have phase velocity, what is phase velocity and what is group velocity. Okay, so the phase velocity is defined by omega bar by k bar, and this first component is completely responsible for the amplitude of the amplitude modulation of the wave, and the second component and the values from the first component is responsible for the phase velocity and the group velocity. Here the group velocity is delta omega by delta k, phase velocity is omega bar by k bar. Okay, so what is our objective is, there is a tool online. Okay, we go to this particular tool and one second. Yeah, so when you go to that tool, I'll send the link later on. No, maybe before the tool will watch the video. So this video is for you to understand what is phase velocity and group velocity. Essentially, you see they are trying to add several different waves, and then they will see what happens to the resultant wave. Okay, just let me know if it's audible.
Suppose we add.
Is it audible?
Yes, sir.
Yeah, it's audible.
Add several waves together to create a new wave. If we change the amplitudes of the waves, the resultant wave also changes. The waves can have different wavelengths. The bottom wave has a slightly different wavelength than the other two. As we move the two other waves, notice how the sum of all the waves changes. The resultant pattern moves at a different speed than the original waves. We refer to the speed of each original wave as the phase velocity. We refer to the speed of the resultant pattern as the group velocity. When we have a wave describing a quantum particle, it's the group velocity that determines the velocity of the particle. Any wave function can be thought of as the sum of waves of many different wavelengths. For a quantum particle with mass, such as an electron, the waves with a shorter wavelength have a faster phase velocity. For classical water waves on the surface of an ocean, the waves with a shorter wavelength have a slower phase velocity. When different wavelengths have different phase velocities, we can have dispersion, where the waveform has a sharp peak at one moment in time, but is dispersed at another moment in time. On the other hand, if all the different wavelengths have the exact same phase velocity, then the pattern can stay constant, and the group velocity will be equal to the phase velocity. Examples of waves where all the different wavelengths have the same phase velocity are electromagnetic waves through a vacuum and waves on an ideal string. If we have waves with the same amplitude and speed, but moving in opposite directions, then we produce what we refer to as a standing wave. Much more information.
Okay, so this is the first video which describes this phase velocity and the group velocity. The second video is very similar to the function which they are using is very similar to what we are using in our demonstration, but then essentially shows what happens to different values of when we had two different waves of slightly different frequency, what happens to our resultant wave. Here f of x, you see it's an addition of these two waves. You see? So when they are in phase, you see some sort of a special thing is happening, and then you can see some sort of a wave packet or group of waves, or you can see a wave, a bigger wave, and then inside that you can see many different smaller waves. Now in a second or so, we will all see quickly how we can represent group and phase velocity here. So this one whole group traveling with the velocity, right? That is the group velocity. And then how does the phase changes with time of the resultant wave? That is our phase velocity. You see, that is our phase velocity. And the most important point is sometimes you see the group velocity exceeds the phase velocity. Okay, that's something to be noted here. Okay, so these are the two demonstration I wanted to show you guys. Is it clear what we are talking about? Phase velocity and group velocity? Any
Yes,
questions?
sir.
Yes, sir. Yes, yes. Yes, sir.
Okay. Now let's see what we have to do in terms of doing the report. So you have this manual. So you follow the same structure. You may not have anything in the calculation. You may not have anything in the diagram or etc. But then this is a slightly different template. Try to follow the same template, but you can exclude few things which is not very suitable for this particular demonstration. Okay? So you have this one particular table where you have different values of delta k and delta omega is given, and then you have a box and then you have the Vg value. Okay, but it's already, we know that when the Vg is nothing but delta omega by delta k, and for all the values here it's the same, but for all the Vg value being the same, is the resultant waves that we get, will it be the same? Then you guys try to infer this. So basically what you have to do, you have to go to that particular I think I wasn't showing the manual. One second. Yeah, so you see this tabular column right below this. So this is what we are going to fill now. For different values of delta omega and delta k, we are going to observe what is the resultant wave pattern, and then what is the value of Vg, which is the group velocity. And then after this particular simulation, you will try to, based on the knowledge that you have gained, you will try to answer these 4 questions. Okay, you have to answer these 4 questions in your report. So this is your target or objective for this particular group velocity and phase velocity. How to obtain different pattern for this different omega and delta k? You go to this website where they have a simulation for this group velocity and phase velocity. You have 3 parameters. One is time and delta k and delta omega. Okay, So you can have this plus button. If you click that plus button, there will be a dialog box will open, and essentially you can insert the value instead of moving this up and down. You can insert the value. So the first one 0.02, right? Similarly here also 0.02. Okay, and then you can have for t, you can fix it for two different place. One for t is equal to 0, another is t is equal to 2. Okay, so for t is equal to 0, for this take a screenshot of this particular area, or maybe take a screenshot of this, and maybe not this because we already know what is. Just write down the value of t of two different cases, and then just take a snapshot of this particular thing, and then vary the delta k and delta omega accordingly. And for each tabular for each cell in the tabular column, you should have two screenshots for two different t values. Okay, then you will see the evolution of the wave with respect to variation of delta omega and delta k. Okay, and then relatively you will do the VG as well. Finally, for the 10th serial number, just give some random values of delta omega and delta k, and then compare it with the other wave patterns. Okay, is it clear that what you guys are going to do?
Yes, sir.
I'm not clear about the table.
Okay, so you have this table, right? And then you have delta omega, delta k.
Yeah.
Values are given here, and then here you are going to paste not in this particular small area. You can have you can extend this table.
Yeah.
Okay, you can make basically you can make it bigger, and then here you are going to paste two different screenshots. You are going to go to the website and give this value respectively, and then for t is equal to 0, you can use this. If you are using a Windows laptop, you can use the snipping tool. Then you can just grab this image and then copy, paste it in your folder. Oh, sorry, file.
Yeah.
Similarly, you change the t value to 1 or 2, doesn't matter. Change it slightly, 0 and 1, or fix. But for all of them, you have to use 0 and 1 or 0 or 2. Again, take a screenshot. For each cell, you will have two images. Is it clear?
Yeah. Now it's clear.
Yes, sir.
And then based on that, you try to answer the following inferences. Okay, it's pretty simple, straightforward. If you have any questions, we can ask.
Excuse me, sir.
Yes.
Sir, the answers for these inference questions should be mentioned in the report which we submit, or we just have to try it ourselves?
No. You have to this 4 inferences. You have to make it in the report.
Okay, sir.
Any more questions?
Sir.
Yes.
Sir, so in the video it was said like the electrons are the wave nature of electrons, we can represent them like the sum of many different waves, correct? No, sir?
Sorry, repeat.
No, sir. That is that they said that for when we consider like matter waves of electrons, the actual velocity of electrons will be like the group velocity is what we consider as the velocity of the electron. So does it mean that it is like made up of so many? That is the sum of so many different waves.
Yeah. So yeah, each and the matter waves comes as a bunch of so many different waves superimposed together. So essentially in that animation, you see wave plus wave plus wave is equal to a wave.
Okay.
So just to represent that that it's always an addition of n number of waves, which will give us a resultant wave.
So like, is it possible for like two different electrons to have like same wave pattern, sir?
Exactly the same wave pattern, not possible.
So like they have their own signature wave pattern.
Yeah. So how can I say, there is always a fundamental limitation there, which is the uncertainty principle.
Okay.
No two waves can be no two waves can be identical.
Okay.
So yes.
Okay, sir.
So when you're trying to measure so this is actually related to the coherence. We will talk about it in the next chapter, laser chapter. We have finished laser chapter, or no, I'm confused. Where are we in theory now? Somebody?
So laser will be going to start.
We are currently in the between of laser, sir.
Yes.
Okay. Yeah. So in coherence also we come across this particular thing, right? So there won't be any two waves which is exactly the same. So there will always be some sort of a frequency difference between them, and essentially, and that's the reason we have a different resultant wave. Is that okay, Akshay?
Yes, sir.
Okay, so I will upload this particular manual in Teams. So that will be helpful for you to create the report. Then I will also give the submission. Any other questions?
So do we have to write any theory?
Theory, try to discuss about the
Phase
like
velocity.
you have the author Beiser also, right? You have
Yeah.
author Beiser, you have this. All of them talks about the concept of this phase velocity and group velocity. Try to describe about that.
Okay. And what about the procedure, sir?
What about the
Procedure.
no, not needed.
Okay.
The procedure is just you run you do that simulation and copy paste it, right? It's nothing much of a procedure.
And so the link that you were talking about, you will post it in the Teams?
Which link? Sorry.
So for the table, value of t.
I've already posted one manual.
Okay.
Sir, for that wave picture.
Which picture? Sorry. Sorry. So I've uploaded the manual. I have so that manual.
Excuse me, sir. Excuse me, sir.
Yes.
So the link for the graph calculation, the wave calculation is in the manual, or we'll send it afterwards?
No, it is embedded in the manual. You can take it from there.
Okay, sir.
So we'll follow the same deadline till Thursday. Okay. So okay, so this time the link for submitting this particular report, I've made it in Moodle, so you guys can check it up in lms.moodle. Is that okay?
Yeah.
Yeah.
Yes, sir.
Yes, sir.
We'll do the attendance now. So few of you have already got back to me with an apologize, apologizing for your act. It's yeah, it's very difficult to accept it, but anyway, I really appreciate the honesty for those who have got back to me. But then still, I do know that there are many more in this list. But it's just not fair, because we are trying to do our best in this pandemic to share the knowledge and effort. And also the point in this virtual lab experiments is it's extremely easy. Like, think if you would have done it in the, actually when you were physically available here. You have to perform the experiments. Of course, it will be much more better, much more nicer, because you get to handle the devices and stuff. You get the natural experience, but then you have to do the report on your own. Yeah, still some people will try to do the copying, but in generally it's not very great. Yeah, it's never appreciated among the faculties. So just try to stay honest, try to stay good, try to learn as much as possible. That's the ultimate goal of this. Okay, again I'm telling you, if you really feel guilty, please, you can text me privately, no problem. We'll discuss about it. And what I was trying to say, yeah, so the attendance link is there. You guys can start giving the attendance. So this is the, again, I finish off with the announcement. This is the last lab. So your lab reports are getting marked. There is a huge number of reports. Of course, I'm trying to involve the research assistants also for marking. So it will take some time. But by the way, we will carry forward with our Viva. So next lab session, you will have your Viva. I have explained the modality of that particular exam itself. So come prepared for that. I'll also give details about what kind of format, and I will also make sure with Moodle if that particular format is acceptable, and it has a 40 MB limit. I will try to do some test runs if any 3-minute video is crossing beyond that memory limit. But then we still can overcome this by many different means. So I can suggest some quick compressing softwares or online compressing tools, or you can try to record this video in as low resolution as possible using your phone. In every possible way. Ultimately, I should see your video, and your explanation should be audible for me. Before uploading, you just have to make sure everything is all right, and within the given time limit, you will be uploading it. Okay, so we will be done with our Viva by next lab class. the following classes, see, we may have a shortage of a couple of hours in our theory class. I will try to do my best in terms of covering the portion. Of course, we will cover the portion. But if there was any need for me to take one or two extra classes, I'll try my best to do it by the lab hour. Like after the Viva, we may have the lab hours for free. We can try to do the theory in the lab hours to cover up the portions. Of course, I will not rush. I'll try to make sure that you guys have got the concept. And if not, if any other extra hour is required, I will contact you guys. We'll conduct an overall survey, and based on your replies, we'll decide on the extra hours. Is that okay for all?
Yes, sir.
Yes, sir.
Yes, sir, fine.
Yes.
Yes, sir.
Okay. Okay, so if you guys have given the attendance, and if you guys don't have any more questions, you guys can leave now. Work on this simulation, so it'll be easy. You'll be done with it within the given time. So you guys can free and focus on something else later on. See you tomorrow in the theory class.
Thank you.
Excuse me, sir.
Yes, yes.
Sir, for the DA digital assignment second one, you asked for us to write 2 pages on any one of those 3 topics, right?
Oh, sorry. I didn't talk about the DA with you guys. Yeah, if you did I post it in the general channel regarding the DA?
Yes, sir, you have.
Oh, okay. Thank
Yes,
you.
sir.
Yes. So I've given digital assignment 2 in Moodle. I hope you guys would have checked it. And yeah, so basically you just try to follow that particular instruction which is there in the Moodle. So you can once again I'll go to that. I'll read it out. So what I've given 3 options to you. You can choose any one on your own, no problem. Let's say nanomaterial synthesis approach, top down or bottom up, but any one of them in detail. You can take one particular example and talk about them in detail, or you can take 2-3 examples and summarize it. Okay, everything in 2 pages. That's very important. You have a title, and then you below title you have give your name and registration number, and then you can follow whatever approach you want to prepare an impressive report. Okay, then carbon based nanomaterials and their application. What are carbon based nanomaterials? Carbon nanotubes and fullerenes. You can write a summary about them. Then industrial applications of nanomaterials. I've shown so many examples for industrial applications of nanomaterials. It's your wish, you can write about anything. Okay, try to write it on your own. Again, there is some similarity check, plagiarism checker which we have. We can run it through. We always have some sort of a 60 to 70% threshold. If there is anything beyond that, your marks will be reduced. Okay. But anyway, try to enjoy this. It's a fairly easy report, and I guess I have given enough time for this. I've extended till Sunday. If you have noticed. So the deadline for this is 20 Sunday night, 11:59 p.m. Okay, and soon after this we will have our.
But in Moodle it shows that the deadline is Saturday, 19 December.
No, did you go now? Like, could you check now?
No, sir, it's saying 20 only.
Yeah. I changed it today.
Okay, it was 19. Like
the other batch student wanted it to have one more day. Then I thought, okay, you guys will also have one more day. But then one thing I wanted to give an announcement. Soon after this, you will also do one more assignment. So then we will be done with our assignments. We can focus on the portions. in a better way. Okay.
Okay, sir.
Any more questions?
Sir, can the physics DA2 be handwritten, or you want it like typed in a Word or text file?
Anything is fine.
Okay, sir.
Always, I just stick to this format. I don't want to impose anything on student, because whichever is comfortable for them, they can do it.
Thank you, sir.
Thank you.
Thank you, sir.
Yeah, I do get many
Thank you, sir.
responses from you guys. Anyway, I'll try to get back to you guys one by one. Thank you.
Thank you, sir.
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 Sir,
Yes.
Excuse me, sir.
I have attendance issue on 1st of December, sir.
Attendance issue on 1st of December. Did you text me? Like, sorry, who was the first one?
Sir, Marunesh, sir, I texted you in chat, sir. I just mentioned the date and the things.
Sir, I
Okay,
am Niharika. I too texted you, sir. I too mentioned the
I
date.
think I didn't. Niharika Arunas. Yeah. I saw your messages. I will change it. Yes. Like, I haven't done the attendance for a while now. I'll do it. When I'm doing it, I'll change it. Okay.
Okay, sir. Thank you, sir. Sure, sir.
Okay, sir. Okay.
Again, just I would like to mention, because it's very easy to miss when we are handling multiple batches. So when I'm completely done with an assignment, I will again post that, guys, please check your attendance. If you still find some kind of an issue, you can get back to me at that time. Okay.
Okay, sure, sir. Thank you, sir.
Okay, sir.
Excuse me, sir.
Yes, Abhishek. Yeah.
Sir, actually, I was new admission, so I have not done lab 1, 2, 3 experiment in my report.
Oh, okay. But then I had it. I specifically created a channel. And
Sir, in that you have
all
uploaded videos. Means in that you have uploaded videos of the missed out lectures, but not for the experiments.
No, I did. Wait a second. So if you go to missed lab for new joinees, so there is one more channel. Maybe it's not visible to you. No, it should be visible, because I made it visible to all. So there is one channel called missed lab for new joinees. Okay, if you go there, everything is there. All the videos of all the experiments and all the data sets, sample data set, the template that you should follow to create report, and the place where you should be submitting this particular late submission. Late submission as in you joined late, and you will be submitting in that particular folder.
Okay, sir.
Please try to finish as soon as possible, so that you won't be missed out of marking.
Okay, sir.
Okay. Any more questions?